Hi there, welcome to a Q&A edition of Space Nuts. I'm Andrew Dunkley, your host, and coming up today, we'll be answering audience questions for a change. We're going to look at lava tubes on the moon and what sort of problems they might cause for future trips to the moon and traveling around on the surface. We're going to, a black hole question. Okay. This one's a little bit different, though. We'll see what Jake has to say. Gravitational waves has come up, and we haven't had a question about gravitational waves in a little while, and that's no joke. We got a whole raft of them there for some time, and then they've kind of vanished, but they're back. And a what-if question from Niall in the UK about an instantaneous trip to anywhere we want to go in the universe. Where would we go? What would we do if we had 1 minute to go somewhere? So that's what we're talking about today on this Q&A edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's back for more. It is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing?
I'm good. You do retain that title, even though you've sort of moved into a different sphere of your career. You're keeping that title, have we decided?
Yes. So you could modify it by saying I am Australia's first astronomer at large, because that makes it more specific. But I do know that there isn't going to be another one, so it's probably a bit redundant. So look, at the moment, I'm calling myself anything I like. Astronomer on the Loose is the favourite one.
It's funny. I was talking in the last episode about how we've become a bit symbiotic and in some of the things we talk about and highlight. It's funny. You are the only Australian astronomer at large. In my radio career with the Australian Broadcasting Corporation, at this point in time, and it probably won't change, I was the only ever regional program manager for ABC West Adelaide. They've never had another one. When I left, they didn't. Yeah, the job didn't exist anymore.
See, we're irreplaceable. That's the bottom line.
And there wasn't one before me, because when I started at the station, it was an outpost, and we got it upgraded to a full regional, and that required a regional program manager, and that was me. And then when I left, they completely tipped over the apple cart, and the job doesn't exist anymore. So we both have one and only positions in the history of our careers.
That might be right. That's right. I think what it suggests is that people thought, we'll try putting somebody with that title in post. And then afterwards, they said, no, that didn't work.
Actually, I can also tell you that happened to me at the Salvation Army. I was installed as a fundraising and communications manager. And when I left, they didn't replace me, but it was a newly created position. And then I was the only one that ever did it. So that's happened to me twice.
You didn't raise enough funds to support another one. That's probably why.
You might be right. Yeah, you might be right. Marvellous organisation, though. Shall we tackle some questions, Fred?
I think so. I think we...
All right. That. Let's get on with it. Our first question comes from a semi-regular sender-innerer named Mikey.
Hey, Fred and Andrew. This is Mikey from LaSalle, Illinois. I just was pondering here about the new tunnels and the collapsed-in tunnels and craters that they found on the moon. Got me thinking to the astronauts that are going to be traversing the moon soon. And do you think that NASA has taken into consideration things like that? I mean, who's to say that, God forbid, the astronauts aren't cruising over the moon and the ground collapses from beneath them and they fall into one of those caves, those old lava tubes that are, we don't know how deep. Just curious what you guys' thoughts are on these. And I appreciate you guys very much. Thanks for the show. Love it. I'm trying to get my 1-year-old into it. He's not really paying attention to it, but I think next year we'll have better luck. Bye, guys.
Thanks, Mikey. Sounds like he's working on his physics, though.
Does he?
One day.
I love the sound of that. That's great.
Yeah. Or Mikey was asking the question while tightening up the head gasket on his old Mustang. That could have been it
too. Could be.
Yeah. That's a good question because, ultimately people will be residing on the moon in one way or another, and they will be traveling. And, the last thing you want is to take your rover out and get bogged in a lava tube.
It would be. It would be a sinkhole, basically, wouldn't it? You'd be driving. It would. Suddenly the ground opens up, and it's happened quite a few times in Sydney recently. I don't know if you've seen that in the news, but I have with various tunnels that have been being dug for transport, not very far beneath the surface, and quite a few of them. Basically, they've opened up. Nobody's been injured or lost their life, but a lot of people have been astounded to suddenly see a hole opening up in the landscape. So it is possible, and Mike is absolutely right. There are lava tubes on Mars. I think, and this is coming from a position of moderate ignorance, lava tubes tend to be where you've got very fluid lava formations. Like we find them commonly on islands like Hawaii, where there's a fairly liquid form of lava that you've got emanating from the hotspot underneath.
I've walked through one.
Yes, I have too. A number of them in Hawaii.
It was quite a modern one. It had electric light.
That's very good. That's very thoughtful of the tectonic processes to put that in. But I think, I can't remember whether it was a few years ago since we walked through one, but we certainly have done it. So you tend to associate them with lava plains. And that would suggest to me that they're likely to be more common in the areas on Mars which were visited by the Apollo astronauts, most of which were lava plains. There was a couple of highland areas that were visited. But we're now going with the Artemis project to the southern polar region, which is much more mountainous. It's a much more ancient landscape. There will be lava flows there, but nothing like what you see in the equatorial regions of Mars. Sorry, of the moon. Get your planet right, Fred, or get your object right. So it's. I suspect there might not be as many, and the risk might not be as high from lava tubes near the poles of the moon as they are in the equatorial regions. But I think it's a non-zero risk, though. I think there is risk attached to it. There's always risk when you go and explore somewhere as alien as the moon is. And we might find all sorts of things opening up. We could even find something unexpected, like, there were many robotic spacecraft were sent to the moon before the Apollo landings, just to make sure that if you landed a spacecraft on the moon, it wouldn't just sink into the soil, because that was always a possibility. Yeah, that it'd be like quicksand, but it was very quickly shown not to be. Now, who knows whether that's the same all over the moon? Maybe if you've got icy material, which is what we're looking for near the moon's southern polar region, maybe the surface will be a lot less stable than it is elsewhere. On the other hand, the risk of lava tubes opening up underneath you might be lower.
Yeah. Would there be a way of testing that before you went on a little sojourn across the surface of the moon, looking for a McDonald's or something?
You take if they're looking for that, they might have a long wait. But what you do is
probably not as long as you think.
No, maybe not. No, that's right. That's a good point. Take your ground penetrating radar device with you, and you might find that there is something underneath that you want to avoid. Ground penetrating radar technology, yes, that's right. It's pretty neat these days, and I don't know that it's the sort of thing that you could carry on your back, but it's kind of getting that way, I think.
Yeah, so, it's exciting that we're starting to reach a point where people will be back on the moon. But yeah, we kind of take it for granted because we grew up, and a lot of us grew up through the Apollo era and have been there before, technically speaking. But you've got to consider that it is a high risk venture. It is a very dangerous thing to do because it's not our environment. There is no environment. It's a barren, lifeless void, and you're putting human beings in it, and all they've got between them is millimeters of spacesuit, and that's scary. It's pretty scary stuff. But Mikey, your concerns are valid. Thanks for your question. We have a text question now from Jake, who is also a resident of the USA. Hello from the USA. See, I told you. And can I just say I love the show? Well, finally, after all these years, Fred, we found one. I've been enjoying it for a few months and can't wait for more. I've got a question about black holes. Suppose you were inside a black hole and managed to shoot a laser perfectly straight away from the singularity. As I understand it, light emitted from inside a black hole would normally curve around the singularity, but if the light beam was shooting directly upwards, which direction would it curve? Would it slow down and eventually reverse direction? Sorry if that made no sense, and keep up the good work. Thanks, Jake. Look, a couple of problems with that concept. Black holes don't like to release light, and they do like to bend things up a bit. So, and getting inside one, not a good idea.
It's interesting. The event that I talked about in the last episode that Manny and I were participating in down at Sea Lake, the Astronomical Society of Victoria's annual Astrofest, we had a panel discussion, and one of the panelists, apart from Manny and myself, there were three others, but one of them was a black hole specialist. And one of the questions that was posed by the audience was, what's it like inside a black hole? And this black hole specialist said, I don't know. And that's because it's a singularity, and we've no concept of how a singularity might work. How just what it means to have a single point in space with infinite density. But doing a thought experiment for Jake, I think he's right. Actually, I think you've got your back to the singularity. You're right next to it. You're in the process of being spaghettified, so you're probably not taking that much notice. But you happen to have a laser with you, which you point directly away from the singularity. And yes, the light just comes back. It doesn't get out. It basically just stops in its tracks. He's absolutely right as well that light, we know light does curve around a black hole, and we've seen that with the Event Horizon images. We see light from the back of the black hole coming out the front, and it's just because the curvature of space is so intense that light has a very small bending radius. And so, but if you pointed directly away from the black hole, yes, it would come back on itself.
Ah, okay, wow.
Actually, let me just qualify that. Let me qualify it, because I need to think a little bit more carefully. That's if it was a stationary black hole or a non-rotating black hole. Now, we think most black holes are not non-rotating black holes. We think they rotate. And we've had this discussion before. How can a point in space rotate? And about what we call the spin, or the angular momentum that it carries with it from when it was collapsing as a star. So I suspect the answer might be different with a rotating black hole. If you pointed outwards, there's this thing called frame dragging, which a massive body drags space-time as it rotates. We know that the Earth actually does that. Frame dragging has been demonstrated to be the case with the Earth. It drags space-time along with it just a little bit. So I suspect that would change the curvature of the laser beam. So I'm qualifying it. Maybe if you stood at the North Pole of the black hole, pointed it upwards there, the light would just come straight back to you because there'd be no rotation.
Okay, fascinating. Thank you, Jake. I mean, sometimes people ask questions that you wouldn't think of, and we get some interesting results. So, and thanks for listening, Jake. Welcome aboard. Don't forget to have a look at our social media platform. Space Nuts Podcast group on Facebook is always a good place to meet other Space Nuts listeners. And I pop my head in there occasionally too. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's take a quick break. right now to tell you about our sponsor, Saily. Now, if you travel overseas or just to a neighbouring country and you need mobile or cell phone services, in particular access to internet data, then Saily is your answer. Saily offers global eSIM services that cover more than 180 countries. And if you're travelling across several countries, you don't have to buy data for each individual country that you're visiting. You can get a regional eSIM, which makes life so much easier. You can even leave your regular SIM in your phone for when you get home, so it's no hassle. The best thing about an eSIM is you don't have to wait for a SIM card to be delivered. You just download it, activate it, and you're all set. Saily also provides 24-hour, 7-day support, so you'll never be left stranded, and they offer business plans too. So how do you get it? Simple. Download the Saily app, choose your plan, and away you go. You can check it all out at our special URL, Saily, that's Saily, no E, saily.com/spacenuts. And right now, there's a 15% discount for Space Nuts listeners. So make sure you use the code word SpaceNuts at the checkout. Again, download the app on your Apple or Android device, choose your plan, and use the code word SpaceNuts for that 15% discount. And you can read more about Saily at saily.com/spacenuts and get a stress-free overseas connection wherever you go. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Yes, indeed. Our next question is an audio question. It comes from, believe it or not, the United States of America. Again, this is Jose. Now, I've got a feeling we've heard from Jose before. It would be too much of a coincidence to have two Joses listening to our podcast. Maybe not. Okay, here we go.
Hello, Space Nutters. This is Jose over in California in the United States. And I was listening to one of your recent episodes talking about gravitational waves. And from my understanding, when two black holes merge, they make a gravitational wave. And it pretty much expands in all directions like a sphere. So that got me thinking, it's moving away from us and it's also coming towards us. So say from the point of view of Earth, if we're looking out to, say, another galaxy or another solar system or something like that, wouldn't the gravitational waves, because from my understanding, they happen, a lot. They happen almost, every day or every hour, what have you. But if we're looking out from the point of view of Earth and these gravitational waves are coming towards us and they're going away from us, wouldn't that distort the view of our telescopes? And wouldn't that have something to do with like the phenomena where you look at a galaxy and it like looks like a mirror? Forgot what the phenomenon is called, but wouldn't that have some effect to that? And then, not really sure if I asked that question correctly, but hope you know what I mean. But also, second question, would the gravitational waves also help explain the expansion of the universe? Because if the gravitational waves are expanding space itself, wouldn't that mean if multiple gravitational waves were happening at once or just happening in general, wouldn't they be expanding space itself? And isn't that what space is doing? Isn't it expanding? So I hope you guys understand both of my questions. I know they're kind of asked, kind of funky, but hope you guys can answer it. I love you guys' podcast. Keep going, and thank you.
Thanks, Jose. A lot of information crammed into that question, Fred, into parts. So the comings and goings of gravitational waves. I suppose the first thing that popped up in the question that I wondered is, do gravitational waves travel as a sphere, expanding sphere? Yes. Okay.
They do, yeah. So, no, they're great questions, actually. And, I see how your thinking is going, Jose. So you're right. Gravitational waves would expand out in a sphere. We tend to visualize them in 2 dimensions rather than 3 because we can't imagine vibrations in a sphere. Well, I suppose we can, but it's like, I suppose, an analog is somebody standing in a paddock and yelling, then the sound will form a spherical shell around that person as they make their noise or whatever they do. So that's fine. That's the spherical nature of them. However, and I think the process that Jose is thinking of is gravitational lensing. He's saying don't gravitational waves distort that process where we've got large masses in the universe, usually clusters of galaxies, which distort the images of objects behind. And the answer is no, and it's because the gravitational waves are waves. They're not a sort of outward pressure. That what they're doing is, they've got crests and troughs. As a wave on, if you throw a brick into a pond, you get these ripples coming out, which have got crests and troughs, but they don't. The waves, will travel outwards, but the bulk of the water isn't traveling outwards. That's just staying there while the wave travels over it, and that's perhaps a reasonable analog for what gravitational waves are like. They're not moving space-time itself. They are passing through space-time with these vibrations, essentially, which is what they are, vibrations at any one point.
Like a shock wave?
Yes, that's right. Yeah. A kind of mild shock wave might be the way to think of it. So they don't affect the overall picture of our, for example, gravitational lensing. They don't change how that works. Space is sort of quietly vibrating there in between the cluster of galaxies and the background cluster that's being lensed. That's all. That is all. You can think of the universe as being a relaxed sort of sea of space-time. But yes, it's got ripples moving through it, which are the ripples caused by gravitational waves, but they don't affect the bulk motion of the space-time or the gravitational lensing. And likewise, that's why it's not gravitational waves that are actually contributing to the expanding universe. The space-time itself is expanding already from whatever the Big Bang was, and gravitational waves are just vibrations moving through that at the speed of light, as we've talked about before. So they're good questions, and I understand why why it's a line of thought that Jose's taken. But I think we're pretty relaxed about the fact that gravitational waves are superimposed on top of the expansion of the universe. Interestingly, the same guy who was asked the question about what's it like inside a black hole was also asked about gravitational waves, because that's one of his specialities. He's working on the successors to LIGO, the Large Interferometric Gravitational Wave Observatory. So, interested person to talk to.
Yeah, indeed. Okay. There you are, Jose. I think we pretty well covered your question. And thanks for your support as well.
3, 2, 1.
Space Nuts.
One final question in this episode, Fred, comes from Niall. In fact, there's a lot to this, so I'll just sort of get into it. Niall is from Northamptonshire in the UK. He's describing the place as very soggy. It might have some gravitational waves if that's the case. First of all, he says, congratulations. Lucky, you are about to be given a once-in-a-lifetime opportunity to travel to any location in the known universe in a special space-warping insta-travel pod. I nearly got there. That will bring you to that location instantly, where it will stay for 1 minute Fred. After 1 minute, its safety mechanism kicks in and it insta-warps you to the nearest coffee shop. That's all it guarantees. Obviously, you might be anxious about the location of the coffee shop, but no further information is available. Questions. So, are either of you taking that risk, stepping into the pod to travel to somewhere remarkable? Its door closes behind you. Now it's a short-term unexpected opportunity with the most precision you can provide the audio navigation system, which can process about a minute of dialogue. Where would you ask it to go? Remember, it departs in 1 minute. Necessary design features. What would be the essential attributes you would like to think the InstaWarp pod has, although it's a leap of faith as you have to step into it without specific confirmation of these, albeit the pod is legendary and known to work. For example, thermal protection. I hope you enjoy your trip. Version 2 of the pod will probably have windows. Put a lot of thought into that. I've got to give him credit. Niall, thank you. So we've got this mechanism that can take us anywhere we want to go. We have 1 minute to verbally upload our requirements. Then it will take us there for 1 minute and then take us back to a coffee shop. That's, I think, what the general gist is. Instantaneously.
So let's...
where do you go?
Let's go to
what do you tell it and so on?
Let's go to the important bit first. The only coffee shops I know that are near Northamptonshire are in Newport Pagnell, where my brother used to live, and they're not bad actually. It's within it's right next door. Is Newport Pagnell to Northamptonshire, where Neil is. So coffee's probably not bad. So that kind of gives you some encouragement to make this trip if you're going to get a nice coffee at the end of it. However, I did lose interest a bit when he suggested that this Instapod doesn't actually have any windows.
Yeah, that kind of floored me too. I was a bit disappointed.
That's why I want to go where I want to go to. Interestingly, Andrew, this was another question, not couched in quite so much detail, but it was another of the questions the panel got night before last in our Q&A at the Sea Lake Astrofest for the Astronomical Society of Victoria. We were asked where we would like to go in the universe, and basically why we picked that. And quite a few of the panelists were wanting to be in the environment of black holes to find out what really goes on in a black hole, particularly the black hole specialist who was the one who basically said he didn't know what it was like inside a black hole because nobody does. So that was interesting. But mine is slightly different, and it's somewhere I've always wanted to go. So I don't need a minute to make my mind up. I might need the rest of that minute, though, to cut a hole in the wall so I can actually look out the window. Because what I want to do is to see what our galaxy really looks like, what the Milky Way galaxy looks like. So what I want to do is head off in a direction perpendicular to the plane of our galaxy, at right angles to it. And our galaxy is about 100,000 light years in diameter. It's a spiral galaxy. We know that. We believe it's got 4 spiral arms, which is quite unusual. We believe it's got a bar across the middle. These are all from observations that we make from our location embedded in the spiral arms. So it's a very tough place to draw a map from. Where we are in the Milky Way means we've got to work very hard to try and find out what it really looks like. But radio astronomers and infrared astronomers have helped us to do that. So we've got some idea about the way the spiral arms are distributed. And you can now find maps of the Milky Way online quite readily. Some of them are very beautiful and some of them are quite detailed. In fact, there's one in my book, Space Warp, as well, which I put in there as a map. Mine's a mud map, though, which is peculiar to Australia. Because you draw it in mud. The bottom line is I would like to go to a point directly above or below the center of the galaxy, about 100,000 light years away. So looking out the window, which I've just made in the wall, you can actually see the whole of the galaxy and see exactly what it looks like. Because my bet is that all our maps and drawings are not that good because we're sitting inside the galaxy. It's nearly impossible to see what's going on. So that's where I would like my Insta-Warp pod to take me, and I'll be quite happy to have a Northamptonshire cup of coffee at the end of it.
Yes, it's assuming it takes you back there, because you could end up anywhere according to Niall. But yes, that's a good one. I completely understand your you being inquisitive about that. Mine's a little bit different. I didn't have a lot of time to think about it, but I actually would not tell it to go to a specific point in space. It would be more of a general request, and my request would be, take me to the nearest planet inhabited with intelligent life, aside from Earth, although the intelligent bit would probably write that off anyway. But that's what I would say. I would have I would give the pod instructions to take me, and I'm using a lot of latitude here, to the nearest occupied planet that has intelligent life. Now, that could end up, I could end up anywhere, or I could end up not moving. It could go either way, because that's probably one of the biggest mysteries of the universe. Are we alone? And that would be a great way to find out. Take me to your leader would be probably one of my instructions. So that's the simplicity of it. As for what I would want on the pod, I would certainly put radiation shielding on it, and definitely a portal at least. Because, if you want to go to another planet and visit another species of intelligent beings, you want to be able to wave.
You would.
Yes, if they're not nice, you also want to, after 1 minute, give them the bird and recede into the darkness.
You do, that's right.
Yeah, so that would be it for me. Yeah,
and I think that's
sort of creative license, I know, but that would be it.
I think that works. I think that's a far more profound answer than the one I gave, Andrew. And I think your point is well made. We simply don't know whether there's intelligence, and just gazing at the Milky Way, as I would want to do, wouldn't tell you that at all. So, well done.
Yeah, but at least you'd know what you're looking at then. You'd be able to come back and go, okay, I know what we look like.
Yeah, and it's not that.
Possibly not. Great question, Niall. We love these what-if questions, so thank you for that. And if you've got a question for us, don't forget to send it in via our website, spacenutspodcast.com or spacenuts.io, and there's a little AMA link up the top where you can send questions via text or audio. Regardless, don't forget to tell us who you are and where you're from, and have a look around while you're there, because there's plenty of things to see and do and buy even, if you so desire. I mean, football teams have jerseys and things that they sell to their fans. Why, we can do that too. We don't have a football team though. That would be very weird. So yes, do visit our website for whatever reason, and don't forget the supporter button if you're interested in becoming a supporter. Someone messaged us the other day, Fred, and said they're going to become a supporter. So we appreciate that, and all our supporters who number in their hundreds now, which is terrific. Fred, we're all done. Thank you so much.
It's a pleasure. That was a really interesting session. Thank you, Andrew, and thanks to all our listeners who are sending such great questions.
They do, don't they? Yeah, a lot of fun. And thanks to Hugh in the studio, who didn't contribute one iota of information or support to us whatsoever, as usual. No, I'm not kidding. I'm not kidding at all. And from me, Andrew Dunkley, thanks for your company. See you on the next episode. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
Yeah, Hugh's going to send a hitman one day for sure. I'm in trouble.